Doors closed. Good morning, everybody. Good morning. How are you? Thank you for making it to this third day and the last presentation before actually going for lunch and probably leaving Milano. I am Roberto Serrano. I am a member of the Connect team in AVEVA. I have been with the company for around 8 years. And I am here today with Damien, who's our product manager and who will be introducing himself a little bit later in the presentation. Let me start with this question. You see the statement here in the screen. Every company wants to be a data-driven company. How many of you have already seen this or are familiar with this statement? Raise your hand. Okay, a fair amount. Let's make it a little bit more modern because this is a little bit legacy, right? Every company wants to be an AI-driven company. How many people here have already heard this and have seen, they are familiar with it? Again, raise your hand. Okay, thank you. Still many people. And now, the following question. How many of you would say that your company is an AI-driven company? Again, raise your hand. Okay, those working in AI, right? Which company? Snowflake. Yes. So the people actually working in AI can say it, but the reality is that even if many of us are familiar with the concept of being and the willingness of the industry and the technology, of being data-driven and AI-driven, is still far away from being a reality. The reason, well, there are many, but there are actually two of them that we can do something about. The first is data. Being AI-driven, AI relies on data, but not any kind of data, data that can actually be used, right? We need the data to be in a specific shape so that we can do something about it. So the first problem will be data. The second problem that we can do something about it is how to do this at scale. And oftentimes when we want to scale things, it's not just a matter of technology. We already have technology. We already have made a lot of progress over the last few years. What we are missing is changing the way we use that technology to do things at scale. That's where we can do also something about it. So what is it that we can do about it? Let's simplify, right? Divide and conquer. Start with the first problem, the problem of data. Specifically, when it comes to operations data, there are a few particularities of it, right, that we need to take care of. If we take a look at the screen, what you can see on the left side is the typical shape that industrial data sets can look like. They might have gaps, they might have spikes. Data is a little bit dirty, but don't get me wrong, this is already great. If you're working on the shop floor, you have your machine beside you, that already allows you to take action. The problem with data is that the further away you are from the source, the higher the quality you need to be able to work on it. And in order to work with data in AI, ML, and analytics platforms, you need the data to be in the shape of what you have on the right side of the screen. There are a few challenges to get there. The first is actually getting the data. When it comes to operations and industrial sites, things are critical, are protected, very legacy very often. So it's a problem and it's cumbersome to get your hands on that data. And the second thing is everything that we need to do to cleanse the data, to prepare it, to put the context, to know what every variable is about, to preserve that timestamp alignment, and to preserve all of those properties that can actually make the data be useful. So what we can do about this is using what we call data views, which is a very elegant manner to convert industrial data sets into ready-to-use for analytics chunks of data that can be reused and that can be governed and exposed through what we call Connect, through the cloud. This is already a lot of value because it's protecting already your industrial infrastructure on premise, and it's already providing a single point of entry, single point of failure, simplifying the architecture, so that you can expose that data to many different tools. Now let's take the second part of the problem, how to do that at scale. And what we see is that as more and more companies invest heavily in data and AI platforms, the value of operations data becomes higher because there's a lot that you can do out of that, especially when you combine those data sets with all kinds of information like supply chain, maintenance, finance, and all of those. But again, what we see with many companies using these approaches today is that to get the data from operations, very often, it's point-to-point connections that are being built. That was great for a pilot, but the problem is when you want to scale, it can create brittleness, it can create many different points of failure. It's very complicated to actually put that to scale and then maintain that into the long run. Of course, If you go side by side with different approaches, you need to deal with every single approach differently, which takes a lot of time to put that to standardization. So what can we do about it? We had seen the data views, the way to convert those data sets into tables that can be used. Now what we can do is expose that data with an out-of-the-box, out-of-the-shelf integration that directly exposes that data into platforms like Snowflake that we have been announcing in this conference. Databricks was announced already some time ago. And what we can do is that we increase the time to value and we reduce the dependency on those point-to-point solutions by standardizing the way that we expose that data without doing any data copy, which is critical because that means that the analyst that's using those tools in the AI and data analytics landscape can see the single version of the truth without creating any other duplication. But that's not all. That's what we are today. To recap, we have created that contextualized view of the data into data sets that can be reused. We have exposed that natively on a standardized manner, on an off-the-shelf manner, plug and play with these tools. But the goal of AVEVA is not just to be able to do these point-to-point solutions at the end of the day. We are the best in industrial data management. We want to expose that data into the unified data fabric, data mesh, where every user can get access to that data, regardless of where there is and what his favorite tool is. So what we are doing is that we are taking this to what I would like to call ultimate agnosticity, and we are improving this integration to expose this data to any open data sharing endpoint, again, avoiding duplication, and Damien will speak a little bit more about that. Many of you might have already heard about the Lighthouse program and the early adopter program, and that's where it's not that we test our products, it's that we prove the value that it brings before we put it to sale officially in general availability. Some of the examples that I put here in the screen are examples that some of them I have had the privilege to be working on, and I wanted to bring to you because this has already brought value to the customers that I have here. The first one is an example of mobile fleet management. And for these guys, there was a lot of value that I have presented several times, but the main one, or the main takeaway for me, is that using this integration that we have been speaking about was the difference between not being able to use those models that they were building and being able to actually do something about this. Because without that integration in the past, by the time they had the data in their platform, it was already too late to take any decision. And as they say, every hour of downtime is millions in loss of opportunity, millions of dollars. The second one is an example in energy transportation where the company is using a dashboard to bring all of the information about how they need to distribute the energy across the different sites that they are providing. They have everything in a single dashboard, but they have come to a point in which the data in the dashboard cannot be trusted. So instead of making the decisions quickly in just a minute, in just a glance, they needed to come back to the data source to double check that the data in the dashboard was actually what was coming out of the data source. So in reality, yes, you're putting things together, but you cannot trust it. So what we were speaking about before, about the data quality. The third one is an example of a renewable energy company, one of our biggest customers in this space, who has been using this technology to improve what they already had in place, providing first a simplification of the architecture and the ability to provide updates on the data that they were using at a corporate level 50 times faster than what they were getting. And when you can get that refresh and that close to real-time, near-time vision of the data, that gives you a competitive advantage, and you are able to react to fluctuations in the price of the market and react to your assets and the downtime and so forth much faster, and that allows you to operate better and further optimize your operations. The last one is an oil and gas customer that, again, I have had the privilege to be working with, and this is just an example of the time to value. I was working with them on the first session to get the data flowing from their on-prem system into their analytics instance, and in under 1 hour, everything was working. The quote from the customer was, and I was surprised, what do we do with the 15 minutes we have left in this meeting? We're not used with things working that fast, right? So just an example that this really works, and this is a way to go. We know it's possible, and we have the responsibility to be providing this standardized way and the best manner to do this integration. And with this, I hand over to Damien.
Would you share the link
Some of them are public, and you can find them in the presenters list. Otherwise, we can speak later.
Thank you so much, Roberto. Good morning, everyone. Looks to be the day of the Braves this morning, because usually the day after following the After Dark party, attending or even presenting is challenging. So thanks for attending. I really appreciate it. Yeah, my name is Damien Rouge. I'm the product manager leading the ecosystem integration with Connect, mainly focusing on the unified data platforms, typically Databricks, Snowflake, later on coming for Fabric. And as a quick recap, October last year, we publicly released the Databricks integration. And today, what the telemetry says is that over the last 6 months, we were about 3 to 5 new end users every week, that have started leveraging the Connect virtual tables component and unifying their industrial data model with their industrial ecosystem stack on Databricks. That said, it's impressive. It's even beyond my self-perspective or forecast that I did myself. So then this year, the roadmap has, let's say, given or driven Snowflake on stage. So this is our main goal this year. We are almost, let's say, code completed, so we are close to onboard customer on this solution. So that said, now we can move to the next slide. Just changing. Is that working? Okay. So the important thing now is to really to answer the question: how do we expose today the different information that Connect hosts at the broader scale? Typically, how do we expose the data in a secure manner, scalable and open, and all this, and for future-proof as well? And all those aspects are, let's say, drive us to a situation where we really have, let's say, this evaluation of the open standard. If there is anything to remain to keep in mind today, this is the concept of open standard. This is really now broadly adopted at the Connect level, and this is the best way today for moving forward for the large adoption. I will expose you what open standard means today. So this slide explains, the end-to-end workflow for first enabling or creating a virtual table. So basically, you may have been exposed to that if you attended the Connect Lounge yesterday. There are a couple of sessions explaining that. So typically, the end user has to, by creating a new virtual table, he has to select a data view that he already created, right? Or he can create that on the fly. And then he passes through several steps for configuring the virtual table, typically specifying the retrieval mode, the retrieval interval, how frequently you would like the virtualization be refreshed, and so on. Then, once the configuration is done, he has to select which type of share, and there are different share types that could be used. We have Databricks for sure, that as I explained for the last year, and today we have now Snowflake coming on stage on that. So you can select the share type that you need, and then expose that to the share created. At the end, you pass to the region summary, and you can say that the table starts virtualizing the data. The second aspect, and this is the key component of this architecture, is all the layers that you see on the screens here are all open sharing based. So that's really important because that's really open standard. The lowest layer you see in the bottom, this is the storage, so that's stored on the ADLS, so Azure Data Lake Storage. Everything goes to a Parquet standard, so that, again, it's another open standard. And the most important is in the middle is the table format, what we call also the metadata. That layer is a combination of the Apache Iceberg and the Delta Lake. That's really for structuring the metadata around the table definition. And by combining both, we use a term which is called uniform. And uniform, if you look on Google or you search about who are compliant with the uniform format, there are plenty, dozens of products, even some that are relatively unknown, at least on my end. that are, let's say, compliant with the uniform format. I will give you a more, let's say, more visual information about that later. And then the latest layer, or the upper layer, is the Unity catalog, which is where we do manage the governance. And again, it's like very, very key because Connect today really deliver governed data that are exposed to any data consumer. And then leveraging the data sharing protocol, which is an open sharing protocol, then you can expose the data to any of the data consumer you want. A lot of screenshots, so move on. So then, yeah, you can, for sure, you can address Snowflake, Databricks, all the key players in the market, but there are also dozens of less known, or let's say, tools like Dremio, like Trino, that there are a lot of open engines that are also compliant with that protocol and that can consume Connect straightforward. The key aspect is the zero copy aspect. So no replication, no ETL, no ingestion. The data remains where it stays. It means within Connect. So one of the last slides before moving to long videos. So you might be safe at the end. Delta sharing. So it's an open sharing protocol, again, an open standard, definitely. And the key aspect to keep in mind, you see in the middle how it works, this is no ingestion. The data remains, so the principle is really basic. The data remains within where it stays, meaning within Connect. And then the data consumer layer will consume the data remotely. So there is no copy between the two, between the storage and the computing. That's also an approach which is broadly adopted by Snowflake for now. They have a lot of initiatives on the that are, let's say, leveraging the zero copy, right? Which is now really the way of going to the modernization or to the modern enterprise data stack. Okay, so first video, just to anticipate a bit, it goes fast, so keep your seatbelt fastened, and then you may miss some aspect because of the timeline that we do have. So creating a virtual table, then you have to first, you start usually by exploring the data within Connect. So you'll have to research from streams or asset streams, leveraging the different data stores that we do have within Connect. Create your own query, investigate the trend, and find the different, let's say, time period that you would like to investigate for the needs, right? So you can specify the time frame that you want, start time and the end time, the time boundaries. You can create, leveraging the cursors and evaluate some of the stats that are written by the system. And you can identify a period of time where you would like you go further for additional analytics later on. Then you have to create a data view. So the data views, once you know which kind of type of data you are looking at, then you can create your own data view, creating the queries. Queries could be entity-based or stream-based. So the entity is way more powerful for now because you have the knowledge graph behind the scenes is extremely performing well. Then you can search for the different assets you want, the different streams, complete the data view, save it, and that you can test the data itself independently from the API console. Then you have to create a share. So this is where Snowflake takes place. Typically, you go to the share, you click on create a new share, and you see Snowflake coming within the drop-down list. You will see also there is the delta sharing coming. I will explain that a bit later. So the end of the workflow return a JSON file where you have all the information you need to implement the catalog synchronization within Snowflake, right? Typically, you have the Iceberg endpoint, and then you have the token returned by the API. Here, this is a single example where you are only leveraging the delta sharing, which is mainly used for Power BI, Tableau, this kind of BI tool. And similarly, you get the information from the JSON written by the API, and you can consume those information for implementing or connecting Power BI, for instance, back to Connect. Then comes the time for generating the virtual table or some of the virtual tables that you need. So creating a new virtual table means, okay, you need to select a data views that is available that you created earlier. You need to also specify some parameters, how you would like to retrieve the data, how far you want to backfill the data, and how frequently you would like the virtual table to be refreshed, right? Once done, immediately the system starts by virtualizing the data and making the data available within the analytics tools or open platforms. Here on the Snowflake side, by leveraging a very simple SQL statement that is going to change, we are going to a smoother implementation. You can create the catalog and see the catalog synchronization. It goes very fast. I apologize for that. But you can check immediately the catalog synchronization, all the components that come with the catalog. I need to stop that now. It's like going a bit too fast. Okay, just hold on a second. So then you can check the data set exposed to a Snowflake, validate the data consistency, the granularity, the density of record per day, just to be sure that everything looks exactly the way that you identify it first within Connect. Then the next level within Snowflake is to leverage what they call the native app, Streamlit. This is the proper term used by Snowflake. And this is where the magic continues. Typically, there are different layers of data coming and blending within Snowflake. In that given example, the industrial data model is coming from Connect, that exposed by Connect, that's for sure. But that also there are different other, let's say, data providers that will be put in context in order to get an additional values. Typically, when Connect say or gives you the what and the when, typically Snowflake can explain the why by extracting the data from their very large marketplace. Typically, the weather data set that they do have is extremely powerful because locally you can really make the asset. Here it is a pump, water pump. You can put the asset in the temperature context and make some correlation in between the different variables. You see there are some the Pearson coefficient here, which is the correlation. Explain how those variables, two variables, correlate to each other in a positive way or negative way, which means they are, when one is increasing, the second one is, let's say, decreasing, which is the negative Pearson rate. When the Pearson rate is positive, then both goes the same way. And higher is the coefficient, better is the correlation. So the native app is really a built-in application, Python-based, within Snowflake, that you can create on your own. We are going in the R&D standpoint also to design that by ourselves and propose an added value to the end user that will come later this year. And then I can restart the video. Okay, so here you can, by scrolling down into the app, there are different layers, different sections where you can make some correlation, identify who are the equipment, the assets that are having some problems depending of the operational condition. And then at the end, even better, you can leverage a Cortex AI from Snowflake, which are going for proposing some prescriptions or recommendations, how you have to handle that situation if the pump temperature is going up with that given contextual conditions, what to do with, and making some estimate on how much money you have spent or you could waste if you are not acting immediately with the proposal. Unlocking the ecosystem is probably one of the key aspects today. I need to admit that a couple of months back, when I really started exploring early at the end, those ecosystems, it's extremely vast, really, really vast. And I'm not joking saying that. There are a lot of products that you will see next slide that are compatible with Connect now and in a near real-time system. That means, again, we are still leveraging the zero copy for everyone. Everyone looks to the same data set. The data truth comes from Connect. That's where it comes from. Here, two ecosystems. We can classify the ecosystem depending on the reference that we are using in a slightly different way. Here, I made a decision to split by the Iceberg REST and the Delta sharing. Both are different, even if leveraging the same behind-the-scene Delta share protocol, open Delta share protocol. Left-hand side, Iceberg REST. Iceberg is like catalog synchronization. This is what is consumed by Snowflake. Good. But there are, again, a lot of other products that are consuming are able to consume this Iceberg REST endpoint. This endpoint also allows to segregate the store from the compute. You can really delegate the computing to any layer that you want. And even in a single company, you regularly see that team to team, they have using or leveraging different computing layers. Some are using, for instance, Databricks or Snowflake, but some other teams, even in the same company, they can go for Dremio or for other open compute engine. Delta sharing is what we call the secure analytics distribution. Is more consumption of a given point, typically a given object within the protocol, within the catalog. You can pinpoint out a given table, consume that table, and then consume the data properly within Power BI, for instance. So keep in mind for now, the Iceberg ecosystem is extremely vast. Delta sharing a bit less. But this is every day is growing. I mean, not every day, but every week you see new candidates, new guys joining those two ecosystems. So that's really extremely dynamic, and the community around those two ecosystems is extremely large. So an example here, left hand side you see the Iceberg, Iceberg ecosystem. So typically. We can segregate that in several categories. You have the compute lakehouse, the SQL engine like Presta, Dreamview, and so on, that I mentioned a couple of times. You have the cloud warehouse. So there are different layers, but all those layers independently can consume exactly the same data sets that we are exposing to the Connect chair. So that's extremely important because irrespective of who is asking for the data, we are all talking about the same data set. There is no transformation in between, right? Anytime. So that's absolutely fundamental because this is the right opposite of the historical way of making this kind of integration where we are leveraging, some ETLs with some ingestion, some transformation. So at the end, having some data replication across the company is always challenging. You have to maintain, you have to operate it, and then at the time you are talking and making side-to-side some comparison between two different analytics, sometimes the data are not the same, because you are using different workflow and ETL for transforming and transporting the data. Second ecosystem is like delta sharing. So very rapidly, and we'll see that in the next slide, which is a very short video, Power BI can straightforward consume the data from Connect. Even further, Power BI mobile. So from new mobile, you get access to the live data from Connect. When I say live, near real-time data, right? But it's extremely important because there is no copy again. So you are on new mobile, you can really scan and screen the data from the machine that you are targeting, and it comes as is, right? So two ecosystems. Next video, and that will be the next slide before ending and going to the questions. Just to give you a bit of the context, the next video, I went to identify some streams within Connect that have a shape that could be easily identified, right, recognized. And then based on that shape, for a given stream, for a given period of time, I've tried to consume that from several different analytics tools. So that's the video that you know, it's the same extract that we used a bit earlier, right? So we can easily recognize the profile and the shape of those different streams, right? Then first go to Power BI. So if you go to Power BI, you search for the delta sharing connector, adapter, right? You put the same credentials, endpoint, data lake endpoint, plus token provided by the Connect workflow, and you rapidly go to the catalog, you consume the object, you can double check the data consistency, and you can plot and train the different data on your Power BI screens, right? So no rocket science, super easy, extremely rapid, and you can use that at your fingertip. Oh, sorry, need to go back. So this is the same example with Power BI mobile. So I have the application on my mobile. I can show you if you're interested after the session. So then the same information I expose, but this is live. There is no refresh, no incremental refresh behind the scene that operates. You directly read the data from Connect. Third one, a Jupyter Notebook, okay, leveraging the Python script. So that's a little bit more coding approach, but that's extremely useful. You can really, I would say, pass through the notebook, discover the namespace, discover the tables and the metadata, and then at the end, review the data set and plot the data set, and you will see that you can recognize that we are talking about the same shape, same trend, right? Next example. Last example would be the Fabric. Fabric again. We are going for having a catalog integration Fabric that will come later this year, but for now, we are leveraging the delta sharing adapter that exists by design within Fabric, and you can have the same experience. So I can extend the video for, not for hours, but for a long time with different other tools that works always the same way. So the source of truth, again, is really Connect at this stage, and that's really important to understand that because whoever you are dealing with for making some analytics, the point that you are analyzing is the same for everyone. no transformation in between, and this is completely governed by Connect. I'm done. So thank you everyone. If you have any questions, before maybe the questions, we still have a couple of minutes. I would like just to, because we have the streaming, live streaming today with the team, I would like to congratulate the team that we do have worldwide. So from California, Arizona, Pennsylvania, India, we have a lot of guys running very, very hard. It's a large team. And what they have produced just for the last 3 months is like unprecedented. So yeah, you can congratulate them. Thanks so much.